engineering and installation processes for cable bus systems. For this presentation, we will begin with discussion of the engineering process for cable bus systems by Advanced Cable Bus, Inc. We will then go over a few features of the engineering process that would help make it easier for the installation process. We will go over some of the installation steps with a few detailed examples. And finally, we will be going over some of the resources that would be available for our customers. So the goal of the process when we engineer cable bus systems is that from the proposal stage all the way through installation, and sometimes even in the pre-design stages with our clients, we will work with our clients to ensure that the installation and the application ends up in a successful case. And that means that the design at the beginning meets all the requirements electrically and physically. And that also means that the installation process, as well as energizing the cable bus all the way through to the warranty period and beyond, results in successful operation for our clients. And we will work to ensure that the design is sensible and practical, and we will make the installation as easy as possible for the installation crews that will work on them. So we start by reviewing any client information and drawings, and this can be at any stage. So we start with a request for proposal, a request for quote, or sometimes just a preliminary request for information. Sometimes our clients can submit layout drawings, single line diagrams, or any hand sketch. And from that stage, we generate the proposal, we do some pre-design work, and we proceed to the purchasing phase where a purchase order is issued and Advanced Cable Bus works on officially submitting drawings for approvals. We will check for any conflicts or physical limitations of the job site. For example, we will ensure that there is sufficient spacing between the cable bus runs if you have multiple runs on top of each other in order to make sure proper ventilation and accessibility for the installers. We will also check against physical limitations, which more often than not show up as minimum bending radius of the power cables. But there are other physical limitations as well, such as interference with existing equipment. We will review our design prior to submittal to ensure that what we submit will fit the application and fit the site conditions and fit the specifications. And we will submit a full set of drawings, including layouts and elevations, all the accessory drawings, as well as any other engineering data that is specified in the order. Once we have worked through the design issues and issued drawings for approval and received the approval, we proceed to releasing the product to manufacturing and begin fabrication. And our fabrication will be based on what we are approved to make. That means that we do not begin a fabrication without the explicit consent of our clients. Once the manufacturing is completed, we package everything for shipment, issue the final drawings and final engineering submittals, include the installation manuals in our package. With every shipment, we will include one hard copy of the installation manual, and we can submit the installation manual separately as part of an engineering submittal to our client prior to shipment. Our installation manuals and our packing lists are cross-referenced to each other and are cross-referenced to the final drawings to ensure that the installation is easy and part identification is not going to be a problem. So first we will utilize our client information in order to successfully come up with a design. we sometimes have to adjust the ampacity of the cable bus system for the site conditions. And this occurs when you have, for example, a job site that has unusually high ambient temperature, or a job site that is near an active heat source, such as a very steamy factory. We will have to design to make sure that cable bending requirements are met, not only inside the cable bus housing, but also in any termination space when the cable bus terminates into an equipment. We will also have to comply with the voltage drop requirements or any current balance limitations. We will be able to provide inductive reactance calculations that will verify the expected voltage drop, the expected current balance, and the expected power loss. We can also supply positive, negative, and zero sequence impedances for fault analysis. And we have lots of custom parts that we can produce and we can design to accommodate tight locations. We pride ourselves on this versatility, and we have made multiple types of custom parts to fit very specific applications. We also can provide recommendations for structural support locations, and the guidelines that we will use will be based on the NEMA VE2 guidelines for support. Finally, we will ensure that the materials that are used to make the enclosure, the materials used for manufacturing all the accessories, as well as the type of cable, meet the project requirements. So the drawings that we will submit for approval will include layout and elevation drawings that would show the plan view and elevation view of the site, showing the routing of the cable bus and the key dimensions that would allow our clients to review it against their site data or review it against their design to make any corrections or make any approvals. For the termination parts, we will submit individual drawings as needed. For example, if we have a transformer box that needs to be fabricated in order to allow the cables to bend into position and terminate on the cable bushings, for the transformer, we will produce the box drawing and submit them as a separate drawing. We will also provide drawings and designs for wall penetrations and other transition accessories, such as a fire stop for a fire-rated wall. And finally, if there are other requirements such as calculations or quality-related documents that are required in a specification, we will provide those as well. Once we receive the approval from our client to proceed, all drawings will be updated to meet all the review notes that we receive. So if we have any dimensional notes or any dimensional changes that are required, we will make those. If we have any changes in the routing, we will incorporate those as well. Finally, the bill of material will be generated according to the approved dimensions. So once we receive the approval from our client, that is when we are able to finalize the bill of material. This will ensure that the bill of material will include material that is exactly of the correct sizes and shapes and amounts that will ensure a successful installation. And our bill of material will include item number, quantity, and a descriptive information as well. The final drawings that we will issue will also cross-reference the bill of material. And this is done by placing bubble marks or match marking numbers next to the individual parts that are identified on the drawings. The item numbers that appear on the shipping list will also appear on the final drawing, and they will correspond to each other. In this example, a straight section of bus has two part numbers associated with it. One is item number 3 and the other is item number 9. Item number 3 is a straight cable bus section of the bottom housing. Item number 9 is the cover of the same length. All these part numbers and the part identification will also show up on the labels that are attached to the piece itself once it ships. This will ensure that by looking at the final drawings, which are included in the installation manual, any installer should be able to look at the drawings, identify the piece they need at any particular point, and install the part accordingly. Once we ship the cable bus and it is received and checked out at the job site, time will come where the installing crew will proceed with the installation. For the cable bus system, prior to installing the cable bus housing, the routing must be cleared and the structural supports need to be in place. Then you begin with laying in the cable bus housing bottom sections from one termination end to the other, including the termination accessories as needed. Fire stops and wall seals can be mounted, as well as the housing bottom section that can be laid out along the routing. The cable support blocks and the covers will be used once you begin pulling the cables into place. As for the power cables, you begin with pulling the cables through the cable bus route using the necessary tools to ensure that there is no excessive tension nor excessive force on the cables themselves, and while installing, you make sure that there is no minimum bending radius violations and that the cable bus housing sections do not scratch or scrape against the cables. When you pull the cable through the routing, ensure that the cables are in place inside the groove of the support blocks before fastening the support blocks. This would ensure that the blocks do not pinch your cables. And then once the cables are all in place and the support blocks have been placed and fastened, you can then proceed to terminate the power cables. For the installation of the housing section, you start with laying the bottom sections along the route on top of the structural support pieces, followed by fastening the housing sections to the supports. And then fasten the housing sections together using our splice plates. For fastening the cable bus bottom sections to the support structure, we will provide mounting clips as well as the hardware for the installation. And when you splice the cable bus housing sections together, you can use the normal tools that you would use when you're installing cable trays. Each splice plate will require 6 pieces of hardware that will include the bolt, the washer, and the nut, and it will be splined and it will dig in and ensure the electrical integrity of the cable bus housing section as well. For installing the environmental seal, whether on a wall or for a piece of equipment, the first step is to remove the bolts and remove the seal block in order to clear the opening. This would allow you to first ensure that the opening in your wall or in your equipment matches your requirement. The seal plate that we provide has a generic size width to it, and you can ensure that it matches your application by trimming the edges as required. The other benefit of removing the seal blocks at the beginning is so that when you place it along the wall, you would be able to mark out the wall opening and ensure that it works. The next step is to line the edges of the environmental seal plate with a rubberized cork tape that would allow your seal plate to achieve a successful sealing against the wall or the surface to which you're attaching the seal. And once you line the edge with a rubberized cork, you can bring the seal plate to the wall to mark out the opening, to mark out the cutting points, and to mark out all the bolts. The first step in installing the seal block and the cable is to apply the silicone sealant along the edge of the bottom seal block, and then return the seal block to its original position. This is followed by mounting the seal plate to the wall and then to the cable bus section that is being attached to it. On the seal plate there will be tabs that will work just like a splice plate when you connect two pieces of cable bus housing together. Starting from the bottom block, line the border or line the center of the support block with silicone sealant. This will ensure that when the cable passes through the seal block, there is a weather-tight seal around the cable. Once you pass through the entire complete row, you then put in the next layer of support blocks and the next layer of seal blocks. Each time you add a seal block to your seal, be sure to liberally apply the silicone sealant along all the edges to ensure a watertight installation. And again, always make sure that the cables are laid flush into the groove before bolting everything into place. Once you have completed all of the seal blocks, you then tighten all the bolts down with the recommended torque. For fire stops, our designs will include a custom designed steel plate for each fire stop along with bracketing materials and a multi-cable transit bulkhead frame that will utilize fire-rated inserts to provide a fire-rated sealing. And the custom designed plates will be designed and sized to fit over the wall opening, and we can either custom design the plate to match the wall opening in your building, or we can also provide you with a recommendation for the wall opening size that is needed, and then we design the plate according to that. And on either side of the wall opening, we will provide a bracket for placing the cable bus housing pieces. Each fire stop plate and frame will be coated with black primer and can be painted to any color as needed on site. In this particular example, it is painted white to blend in with the wall, and you see the cable bus piece approaching it. The installation examples for the fire-rated inserts and how to tighten and achieve a fire-rated seal are available as online video clips that are provided by the fire stop manufacturer's website. For the power cables, you begin by pulling the power cables along the cable bus route. Prior to pulling the cable, you must always make sure that the cables will fit inside the support block grooves before fastening the bolts. And before pulling the cables, you must perform the necessary calculations or the estimations to ensure that the length of the cable and the type of the routing will not result in excessive stress on the power cables themselves. Once the cables are fit inside the support block grooves, then we can fasten the through bolts and the fire stop parts as well as the environmental seals. when you pull the cable, always make sure that there is plenty of room and plenty of cable length at the ends to terminate the cables without straining them. During the engineering and release phase, Advanced Cable Bus will ensure that there is enough length specified for each termination end so that the cable can comfortably bend, terminate, and still reach the terminal points of the equipment on both ends. When we ship the cables, we will also include a certain percentage of overage once by design, and on top of that there will be overage due to the cutting tolerances of the cable manufacturer. Always make sure, especially during the elbows, that the cables fit in the groove and form the elbow shape. Otherwise, you might end up pulling the cables too tightly, and then when you try to terminate the cables, you end up slightly short. Once the cables are in place, you terminate the cables with the compression lugs and the heat shrink or cold shrink termination kits as required, depending on the voltage of your application. For further information, please contact us at the contact information shown here. Any questions and comments are always welcome.